Oh no, I was muted.
Happens to the best of us. It's all good.
Okay, now we're here. What I was saying, I thought to myself, man, you have to make sure that you don't that you unmute yourself. So now that you're here, I titled this event the Unified Analytics Platform CelerData. For me, analytics platforms are something very interesting because as an engineer, we're not just doing the engineering for fun, right? We want to get the data to the analytics. We want to get people to do something with it. So that's why analytics platforms for me are very interesting, and also how you do it. And that's why I invited you two, uh, Lee and Rachel, where you're going to show us how you do it with CelerData. And yeah, let's have a great event. Uh, Welcome to the audience. I already see a few people here. AK, my initials. It's not me, but Omar and Ignas and Tyler. Welcome. If you have questions, Rachel and Lee are also going to answer these questions during the stream. So I'm going to bring it up. So share them in the chat. And Lee and Rachel, please, it would be cool if you say a few words and introduce yourself.
Sure. Thanks, Andreas. My name's Li Kang. I'm in charge of the overall go-to-market strategy at CelerData, based out of Seattle area, and very excited to be here with you guys.
Hi, my name is Rachel Bador, and I'm a solution architect at CelerData. So I spend a lot of my time hands-on working with the software for CelerData and for StarRocks. I'm really excited to be with everybody today.
Oh, yeah, welcome. Analytics platforms, challenges. We were talking about this before a bit, Lee. Can you give us a bit of an introduction into like what's an analytics platform? Where are the challenges in this?
Sure. Yeah. Well, let me start with a couple of slides to facilitate the conversation. Can you guys see the?
Yes, we can see the slides.
Already. So let's just start with this overall analytics concept and platform, right? The analytics that we are all familiar with, in the traditional way, I categorize these three different, or summarize as three different characters, right? One is batch, where usually getting data through ETL or ELT on a daily, weekly base. And number two is the targeted users are usually internal users, analysts, or senior managers, executives, and they use these analytics, the results of this analytics platform for strategic decisions, right? And this platform is usually a standalone, used for reports, dashboards, right? If you think about it, these are the analytics that we are familiar with, and they are still, these are still very common and relevant features in today's analytics world. But analytics platform in general, they're also evolving, right? We're seeing, the timeliness of this analytics platforms are moving from a batch-based to a real-time analytics, right? Real-time means from the moment the event happens to this event being available in the insight in your, whether it's your decision-making process or your reports or your dashboard or your calculations, right? The delay is only seconds instead of hourly or hours or days or weeks, right? So this real-time analytics. And their target users are moving from internal users to external users. External users means your business partners, right? People are using your platform for doing their businesses, right? Or your end users, right? Not just the analysts or executives. It can be just users like you and me, using this application, and we want to run some analysis or getting the latest recommendations. Those kind of use cases. And then naturally, right, these platforms are moving from a standalone format to a embedded format. That means this functionalities is built into today's applications or websites, right? So it's part of your normal business workflow. It's not a separate function let's look at this report, let's look at this dashboard. While you're conducting your normal business, running your normal transactions, you need this analytics capabilities. So to sum it up, right, analytics is not only strategic, part of the strategic decision making, but it is becoming part of the daily operations of today's businesses. That's the overall trend, for the analytics platforms. And that's what I meant by a unified analytics platform is, we're not just talking about a standalone, a separate, platform that designed either for batch analysis, for some real-time operations, for internal users or for external users, right? We need a platform that to unify these different scenarios, different use cases onto one platform. So you're not dealing with a situation, you're telling your users saying, hey, are you running some ad hoc analysis? Well, use this product, right? That's your query endpoint or query tool. If you're doing some data science analysis, you need some real-time calculations, you point to that tool or that solution, right? And as the data engineers, then we maintain different pipelines, different products, right, and even different copies of data. Instead, we unify all these data and pipelines and the analytical capabilities onto one platform. That's what I meant by unified analytics platform.
I really like that because when I see this image here, this reminds me like that a lot of companies start here in the middle, right? They get themselves a platform where we have some data, let's get that data or export that data once a day, create a report or put this into a database, and then create reports and look at the daily information or the daily updates. And then the problem is, at some point they come exactly to that problem where now we want to see quicker results. We have data that moves very fast. Now with that platform that we have, that's not possible, right? And then they build another thing, and like that's a good way of doing it, actually, and keeping in mind that's required. I don't know if that's just time, that a few years ago nobody thought about this, or people were happy with the one in the center. What do you think?
I think it's a part, or the main reason is it has been very difficult to build a real-time analytics platform, right? So we in the past probably 5 years, we saw the growth of real-time dedicated solutions for real-time analytics, right? And then we have this traditional batch-based analytics, and they have evolved from in the last almost decade, right, from a more traditional platform to the big data and the cloud platforms. But we're still seeing this separation of batch-based use cases and solutions, and then on the other hand, you have real-time use cases and the real-time solutions. And there were even several years ago, there was a term called Lambda architecture, right? Not to be confused with AWS Lambda functions or Python programming languages, Lambda function capabilities. This Lambda architecture in the big data world talks about you have your slow path or batch path. That's your batch analytics pipeline, and then you have this quick path or real-time path. That's your real-time pipeline. And then behind the scene, you have best practices to reconciliate the data, to resolve any conflict, and to combine the result or move from the real-time, almost like a temporary repository, back into your long-term batch-based repository. Right? So lots of engineering effort has been
exactly
working around this problem.
Because when I was working on that one project where we're basically doing analytics on machines and predictive analytics on machines, there was a real-time part of the Lambda architecture, but it was very customized, right? It was not like, okay, let's do some ad hoc queries, and like it was very, very customized. There was a use case for it, and it was as I said, was difficult. We had a lot of engineering to be done to actually realize that.
Exactly. So just a quick history about CelerData and the Starrocks, right? The Starrocks is the open source project built by started by the CelerData team. So this project was started about 2.5 years ago, and then we open sourced this project last year, and the company was officially CelerData was launched earlier this year. So that is a relatively short history, but we have gained over 3,000 enterprise customers. You can see I listed some of these, some of our well-known customers here. And in terms of where we fit, right, we fit in between the presentation visualization layer and the backend data platform repository layer. So whether it's a batch-based data ingestion or real-time ingestion, synchronization, or federation, different format, different query patterns. Starrocks as a unified analytics engine can support these different scenarios and to feed query analytics results to the backend applications. So our typical use, sure.
That fits to the question here. I'm guessing you get to that, but I just want to bring this in. How would you introduce CelerData in a company's data architecture? For instance, the company uses on AWS Kinesis, Redshift, and Tableau for reporting.
Right.
That I think that's what you're explaining here. It sits basically in the middle.
Yeah. So let me just this will kind of explain talk to that point, right? How do we use Starrocks? At high level, we have these three different use cases. Number one is your more similar to the traditional OLAP database concept, right? Data is your raw data is in your data lake, S3, or on premise is HDFS, and we can ingest data and through run the transformations and ingest data into a Starrocks. So Starrocks is used as a database for online analytical processing purposes. That's a batch processing mode, and it's more for a OLAP, high performance queries. And the second scenario is as a Lakehouse analytics engine, right? So data is stored in the data lake, and you have a table formats on top of this data lake, right? Whether it's a Hoodie or Iceberg or a Hive meta store. And Starrocks can be used just as a Lakehouse query engine. We will pull the metadata from a Hoodie or Iceberg, and we're going to have a Delta Lake support coming out next month. And then you can just run the query without moving data into Starrocks. And the third use case is real-time analytics, right? The same platform, we can connect to either a CDC, chain data capture stream, or a Kafka stream. And you may even insert a Flink job to run some data cleansing, simple transformation, and then have a Starrocks to run the analytics on top of that data streams. So these are the three scenarios, right? So for example, if it's maybe we can switch to a different streaming sources. In your question, how does that work on the different clouds, right? And we can connect to different database sources or different stream sources, different data platforms, different metadata catalog table format. But in general, these are the three ways to use StarRocks. Does that answer your question?
Yeah. I think that answers the question. Let me know in the chat, AK, if that answers your question. But I think that makes it very clear how to integrate this.
Cool. Yeah. Okay, so I just want to share these two benchmark results, right? Because when we talk about analytics engine, database, or Lakehouse analytics, right? These are some of the common solutions, and we all get asked these kind of questions all the time. How do you compare to some more well-known technologies, right? For example, Lakehouse and Druid are, they're all both great products for real-time analytics, and the Trino obviously has been a very successful in terms of a batch based Lakehouse analytics. So how does StarRocks compare to these products? Right? So we run we use a standard benchmark test data sets. On the left, this is the SSB benchmark testing against Lakehouse and Druid, and on the right is TPCH test set against Trino. So you can see we have a great performance advantage over these standard test cases. Now, obviously, for each user, each scenario, the result will be different, right? So we encourage you to try this product in your environment with your data, and we'll be happy to support your evaluation.
Oh, that's cool. Yeah, that makes sense. Some people are, or say that with these kind of benchmarks can be difficult to reproduce, right? Because the data is very different in the use cases. But it's good that you give people a hand at that. And
yeah, and that's a good point, right? We publish the whole test setup, including hardware configuration and the script used to generate these tests, to run these tests, right? Everything is publicly available on our website, so you're welcome to reproduce it, and then you can try different data set, right? And but I think probably at the end of the day, you want to run the POC in your own environment and to with your data, your test case, to compare these different solutions.
Yeah, makes sense.
So what's the difference between the CelerData and the StarRocks? Right, StarRocks is the core of a CelerData product. It will that's the open source project, and on top of this open source project, we offer a cloud offering. It can be it's a fully managed services. Currently, it's only available on AWS, but it will be available on GCP and Azure soon. And we also have an enterprise offering, which provide auto deployment, operational dashboards, and enterprise security services. These capabilities, and we CelerData works with a different ecosystem, for better integration with different components. And obviously, tech support, right? Service level agreement based tech support. So I just want to emphasize all the functionalities or performance capabilities, right, of the product will stay in the open source in StarRocks. So you can take this open source project, deploy in your environment. You'll get the best performance in terms of query and analytics capabilities. CelerData is really, to make StarRocks readily available for the enterprise or commercial customers. That's the main difference.
how does this work with CelerData? So is this more like Databricks, where you actually, or the customer actually then has in their AWS account the resources or the instances, or is this more like other platforms where you are completely in charge about for the resources, and the customer doesn't even see the resources? Just say, okay, I want to deploy
Yeah,
it on
that's
AWS.
a great question. Actually, we are going to have both scenarios in our cloud offering. We'll support both formats. Right now, we just rolled out this what we call BYOC, Bring Your Own Cloud offering, which is very similar to Databricks offering, like you mentioned, right? Data will remain in clients VPC. That's but we help with deploy the resources and install the software. All those management functionalities will be managed by our cloud offering.
Yeah.
And
That's cool.
next year, we're going to have a multi-tenant SaaS offering. It will be more similar to the cloud data warehouses that we're familiar with, right? So in that scenario, we are going to manage all the resources, and customer will just insert data or ingest data into this CelerData cloud environment, and without seeing or worrying about any infrastructure or resources. So we've seen got requests from customers for both situations. Some customers would like to have their own infrastructure but have CelerData managing for them. And some customers just want to 100% hands off.
Without knowing anything about it, I would guess that the larger enterprises, they are looking for hosting it themselves, and more the startups and the early adopters or the early projects, they're going for the fully integrated version, right?
Yeah, I think you're absolutely right there. Yeah.
Interesting. That's cool. Okay. Interesting.
Okay, I think I'll just hand over to Rachel to show some of the product architecture and then give us a demo.
Cool.
Sure. Yeah. So you can share my screen. I'll be talking a little bit about our product features. Feel free to ask questions and interrupt me if I miss anything or if there's any confusion. So first, I'm going to start with a few of our key features. So one of the biggest things is speed. We are a really fast database. So you can actually achieve really fresh, fast data without denormalized tables. And I'll get to that more when we go through the architecture, but you don't need to do a ton of ETL or put everything into a wide table to achieve the same amount of quick latency. You can join at the edge. The second thing is real time. So it's fresh data that can come in through streaming, and it can be data from, like minutes ago. You don't need to wait a really long time. So that is another great feature. The third thing is concurrency. So we were designed with concurrency in mind to scale. And this kind of ties in with the fourth feature, which is operations. So we are pretty easy to scale. You can add or remove a node as needed. And that is designed to work really well with thousands of users. And then because we are fully vectorized and our architecture is vectorized down to the hardware level, our concurrency, we can support really, really high concurrency because we're optimized for it. So I'll go through a couple of the key engineering features, kind of like the why. So our cost-based optimizer is designed for us. It's not ported over. It's actually designed with the vectorization in mind. And then again, we're fully vectorized down to the hardware level. So every component within StarRocks is designed for vectorization. And that kind of goes in place with the pipeline execution as well, that we're able to really efficiently process queries and get the most out of every CPU cycle.
Yeah. Can you explain the vectorization a bit? What exactly does that mean?
So we can do like multiple different we can process multiple things at once, right? So that's like the parallel architecture. So that's all the way for us down to the like the ISA, the hardware level. We're operating multiple operations at once for the entire data set. So in a lot of other software, you might hear that it's MPP or hear that it's vectorized, but it might be done in the software level, whereas we're designing our entire product to work with that vectorization.
Okay.
So we also offer a couple things to help with the optimization, such as the intelligent materialized view, and we have other optimization techniques that you can use. And we are fully SQL compliant, so it's an ANSI SQL interface, and you can actually connect to anything. We have I'll show this in my demo, but we have a MySQL interface. So you can connect to anything that MySQL can connect to.
Okay.
So Lee showed this slide already, but just to kind of give an overview. So we have a couple different ways that you can work with StarRocks. So you can have the data real-time from like a CDC. You can also have real-time data from like a Kafka stream, and you can ingest data in batch. You could also keep data in your data lake, and it will never be persisted into StarRocks. So it's almost like federated. You could do that with like Apache Hudi or a catalog manager. So that allows you to not need to actually ingest the data into disk. There's a lot of different ways that you can design the StarRocks architecture and still get that great performance. So at the top, it shows the different ways that you can connect to StarRocks. So again, we can connect through the MySQL interface to a BI tool, or you could integrate it into your own application. All right, and we talked a little bit about this, but to go into a little more detail about that denormalization process. So when we say denormalization, what we're talking about is with a lot of architecture today on other systems, you might need to actually join your tables in advance into a single wide table. That's so that it will work with your analytics engine or your database. So that's the case for like Druid, Pinot, ClickHouse, you can see on here. This is a typical architecture that you would use for that. So that ETL process of joining into a wide table can be really expensive. It might need to happen over a really large cluster and be a lot of like processing. So with CelerData or StarRocks, you actually don't need to do that, or you can at least minimize a significant portion of it. So you can actually join at the edge. You can put in your tables individually. You don't need to do this big ETL process, and that can really cut down on your TCO. So your total cost of your entire data system will be decreased if you use StarRocks, because you won't need to do this really intensive process of joining the tables in advance. And it gives users a little bit more flexibility to query what they want to query.
Yeah, I'm seeing this in terms of tools. Like most likely in the upper part, you want to have some ETL tool or some processing tool that actually does the transformation of the data, right?
Yeah, I think some people do it over like Spark. So, you know, they'll have to do it's actually a pretty intense process of doing the joins on the tables. It's not always super straightforward. So it helps because we're able to do the joining at the edge where we don't need to require that big process, we're able to be faster and fresher.
Okay.
And so just to zoom in on the StarRocks architecture itself, so we have two types of nodes. So we have FE, that stands for front end, and then BE, that stands for back end. This is a really simple architecture. You'll notice that there's no like zookeeper, there's no coordinator node. So a lot of other analytics tools will require a lot of different processes in the back end, or a lot of different other software tools. And if you've worked hands-on with those before, I'm sure you guys all know it can be really complicated and difficult as you add more. So we keep our architecture really simple. We don't rely on third-party dependencies, and everything is designed for StarRocks for that vectorization. And then just one thing to point out here. So this does show with the storage engine in the backend node. But again, you could federate to a data lake. So you can choose to ingest the data, or you can federate it. And then eventually, we're also coming out with a new feature that will allow you to use object store. So your storage and compute will be separated. That'll be next month.
Oh, okay.
Okay, so I'm going to show you guys a brief demonstration. So I am going to be using CelerData Enterprise. So again, CelerData Enterprise is our enterprise product, but it's all built on StarRocks. So that performance you're going to see with CelerData Enterprise, you're going to see in StarRocks as well. I have a really simple cluster I set up in AWS. It's got FE and then 2 BEs, so 1 front end and 2 back ends. I put the storage on SSD, and then I brought in SSD benchmark data. So as we were talking about earlier, that's just some benchmark data. We have a really easy way of generating it. So I was just playing around with that. I got 600 million rows of data. So it's a pretty large data set, and I have 2 VMs. So this data set is also, it's, if you guys aren't familiar, it's just like a retail data set. So the fact table is this line order, and then you have a couple different dimension tables that are joining to it. Mm-hmm. So let me get started. I'm going to switch to the demo. So let me start by just going into here. This is our UI for CelerData Enterprise.
Can you zoom this a bit?
Okay,
because,
yeah, sure.
Or make it full. Yeah. Sure. Cool.
So this is the UI for CelerData Enterprise. So this is one of the features that you get with the enterprise product, is this great UI that gives you a lot of monitoring tools and information, makes it really easy to scale. And it's a great way for me to show it to you guys so that you can see kind of more visually what it looks like. So I am going to go show you, I can show you just a couple I have a couple different databases. I'm not going to show this today because, but I do have it set up with, so you can have both ingested tables and then you can also have it federated. So like I was playing around yesterday with Elastic and I had it federate, or I had a query to Elastic. So, you know, that's why it says 0 for the storage, because it's actually the data was stored in Elastic and I was querying to it. Cool. So you can have both at once and you can use them together. So in that sense, we are separated from the storage a little bit. And then this is the data that I'm going to be using, the SSB. It's compressed after it gets into StarRocks, so it's 21 gigabytes, but I think it's a little bit more than that when you generate it, like when I did the generation. So we do compress it a little bit once it gets into StarRocks. But again, 600 million rows. So I am going to go ahead and go to the editor just to show you guys a little bit about, just to go through. This is just a SQL editor. You can use any MySQL connector. So you could just use any interface to query on StarRocks. I'm just going to show you the one that we have embedded into our IDE or our UI. Mm-hmm. So I'm just going to set this so that we're able to see the query plan afterward, because I'm going to show you guys that afterward. And then I'm going to select using the SSB dataset. And the first thing I'm going to do is just run a query to show you guys the number of rows. So I did select count all. You can see this number is kind of hard to read, but it's 600 million. And you can see how fast that went. So that was querying one table, line order, and doing a count all. I didn't do much optimization for this, so I haven't added on really any optimization. The main thing I've done is just the way that we design the tables. We have this way of co-locating join keys. So if you know how your data is going to join together, you can tell StarRocks how it joins together, and then it will store them. Store the joins like together in the storage engine. So as a result, you have less shuffle when you're doing the join. So that's one of the only optimizations that I even have on this data set in this environment. So the next one, I just wanted to show you guys what it looks like if we had 4 joins. So these are not small tables. Even the dimension tables are up to, I mean, you can see over here, but like the part table is 16 megabytes, even compressed. I think it has 1 million rows of data. So we're going to be joining to 4 different dimension tables from the 600 million row table. So this is a pretty heavy join. And then we're going to do an aggregation. We're going to sum up all the revenue. So the query that this is, I wanted to show you like what the joins, but just to like give you some business context, this type of query is finding the total amount of revenue from the transaction data set. And then it's sorting it, or it's filtering it by where the part brand is equal to a certain part brand, and then where the supplier is in Europe. So I'm going to run this query. And you can see like relatively quickly, even without added optimization, I didn't do any aggregation in advance, how quickly I was able to just run that query, even though it joined 4 times. So we had no denormalization there. It wasn't joined in advance.
Wow.
So I'm going to show you, so one of the features of CelerData Enterprise is we have this nice UI for showing the query plan. If you guys, I think this is pretty common. You'll see, if you're familiar with like different services also have query plans, so you might have seen a UI like this before, but it's really nice for showing kind of how our software works. So I won't go into too much detail, but you can kind of see how it's joining together, and then doing the scan, joining, and then it's using the copy space optimizer to optimize this query plan every time we run it. So I just wanted to quickly show that. And that's a feature that you'll get in CelerData Enterprise, but you can always see the UI, but you can always see the query plan even through the CLI.
That's cool.
So are there any questions so far on CelerData Enterprise?
Well, there is one question, but I think that was more for Lee. So when I see this here, this query optimization, this reminds me also a lot of like in Spark, where you see your plan, and it's interesting that you have so much detail here, that you can see exactly, okay.
Yeah.
In
Yeah,
which,
it's also, yeah, because a lot of it's automated too. So again, like I didn't really do any manual optimization, but then we do allow you to see kind of like what kind of optimizations.
but if you would want to optimize this manually, you would also do this just in like SQL, like you've done it.
Yeah, so we have a couple different ways. So you can use, like, we have indexing options. We have ways of doing materialized views, and different ways of doing the table as well. So again, like I did have the table co-locate the joins, which means that the joins are stored together, the join keys, so that there's less shuffle. There's different architectural decisions you can make to optimize as well. Like one thing I did is I only have 2 nodes on this entire cluster. I think in the real world, we probably would have more, so it would go even faster. So things like that are architectural decisions. But you can add like an inverted index. You can add a Bloom filter index or a bitmap index, and a couple other different ways that you can optimize.
Yeah. Yeah, it makes sense, because once you know, or when you know your data set, you know how to optimize based on the queries that are going to be expected.
Yeah, and our cost-based optimizer automatically runs in the background. So you'll have that as well, just automatically.
Yeah, one of the probably the fundamentally differences between StarRocks and CelerData compared to other query engines is how we approach this performance optimization, right? As Rachel mentioned, there are many techniques, indexing, materialized view, pre-computation. Those are the way we look at them at CelerData or StarRocks. Is we think those are like almost like icing on the cake, right? They're great, but those are techniques should come after the great query engine, the core engine itself, and that's where this cost-based optimizer can help us. Is with this cost-based optimizer, we're able to fundamentally improve the performance, solve this, especially join the query performance, right? Once we solve that problem, without building this denormalized table, then the rest becomes much easier, right? On top of that, you can add indexing. Indexing comes with a price, right? It's not a you don't get performance for free through indexing. So it's something we can leverage to further improve the performance, but that's not our main approach, right? Compared to some other engines. Similarly, pre-computation or materialized views, and those are the techniques we can use to further enhance the performance. But fundamentally, is this improving the query engine, make sure we can run this complex aggregated query against large data set on the join tables. That is the how we approach this problem.
So Rachel, you showed us here basically a worksheet how you can do that, right? So how I'm guessing, or I would say, this is not always the case, right? You have analysts who sit there on their Power BI or something, and they want to see something.
Right. Yes. This wouldn't be how your analyst would query the data. I don't have a BI tool set up now, but I can kind of show you, so because we have the MySQL interface, we can connect into the major BI tools. So you can connect in with anything that uses that you can connect in with MySQL. So for example, I actually have it pulled up now, but this is the Starrocks backend. So this is the like a CLI. I know it's a little hard to read, but I have to log back in actually. But so this shows you the MySQL interface. So you can, this is just a command line MySQL interface, but anything that uses that you can connect in with MySQL, you can use. So you could use a BI tool at the front end.
Yeah, because it can be very annoying that you need some add-ons, or you need to download stuff and configure stuff just to access the data. And if you have something like that, like a MySQL interface, it's very simple to integrate. That makes sense.
And you can integrate it in an application like we did for our front end, right? So you could have an application that integrates with MySQL, and that way, if you had a custom application that you were using for your company or your organization, you could integrate Starrocks into it.
Cool. And from here, you can also do the management of the nodes and everything.
Yeah, so I can show you that. It's actually pretty cool. I don't know how in depth we want to get, but here's my SSB. So this is a really wide table, really large table. So I'm just going to show you, this is through our UI. We can kind of take a peek. So this is the biggest table. It's line order. And I can show you, so there's, if I go into the partitions, I can actually see where all the data is stored, like the different tablets. The way that we distribute data across the cluster is also like really efficient. So we're able to eliminate like hotspots, and we're able to make sure that the data is distributed in a way that makes sense for query efficiency. So you can kind of see here, this is the 2 nodes. So again, I only have 2 nodes in this cluster, but you can see how the partition is distributed across the 2 nodes. And then, so some people will choose to replicate. This one's not replicated, but you'd be able to see that as well.
Yeah, okay, of course. If with 2 nodes, it makes no sense to replicate the data.
And just one more thing is like, when I went to add, so I was originally using this as standalone, and I added another node just to practice it yesterday, and it was really easy. I was actually very impressed. So there's no like rebalance procedure. You just, it's automatically rebalanced and redistributed across a new node when you add a new node. Same with when you remove the node, it'll be automatically redistributed.
Okay, cool. Okay. That looks good.
Okay, great. So I can just kind of summarize what we showed if anybody joined in the middle of the demonstration. Let me pull up the image again. Sorry. So we just showed the demo with CelerData Enterprise, which works on top of Starrocks. So we were able to show both Starrocks and CelerData Enterprise. This was a 600 million row transaction data set. And we showed you guys how you could join at the edge without having that that ETL process of doing the wide table. And so you can do a architecture like this, or you can choose to have your storage separated. So yeah, and if you have any other questions, feel free to ask them. But if there's no other questions, we can move on from the demo.
Guys, put the questions for Rachel in the chat if you have more questions. In the meantime, I'm going to ask one, Lee, because there is one. I think that's right down your alley, Lee. There was one.
Yep.
What type? That wasn't it. Wait a sec.
Okay.
Yeah.
From AK, right? What type of trends are you seeing with clients moving over to CelerData, Snowflake, or what we're seeing is you can put it this way: start with performance challenges, but the determining factor most likely is the cost associated with the other technologies. And let me explain why. Right, and the first impression is you look at this, whether it's a data warehouse or another query engine, and they get slow query performance, and that can be, the funny thing about performance is it's all relative performance, right? Compared to different technologies. When you move from MapReduce, a job may take tens of minutes, and suddenly you move to a new platform, and your query result comes back in like 15, 20, 30 seconds or 5 minutes. You're pretty happy with it. But after a while, you realize it's still not fast enough, right? I can't really do my interactive analysis. I can't keep asking questions. That's when you look at Starrocks, everything comes back within a couple seconds, right? And that's the use case. I'm going to talk a little bit about, how Airbnb uses Starrocks for this reason. And so that's the first thing is, wow, this tool is really fast. But what that means is, like Rachel mentioned, right? We don't need to build the denormalized table for majority of the use cases, and we can get this sub-second query latency on the join tables directly. Not only you get great performance, but also you're going to cut tons of hardware resources, right? All those ETL jobs, the ETL servers, or the extra nodes in the cloud to run, if you run in the ELT fashion, right? To run those transformations and data loading jobs. And also the time you saved to build, to populate those denormalized tables. That all those translates to significant cost saving. And that's eventually will drive customers to move to this new platform is great performance with a much lower cost point. And the Snowflake is one of the technologies that we have customers have moved off of to onto the Starrocks platform, right? They run those queries, complex analytical queries, takes a long time. And the funny thing about cloud data warehouses, we always say expensive queries, right? In the old days on-premise, in the on-premise days, expensive query means slow queries. But in the cloud world, expensive queries literally means expensive queries, right? So that's probably the most important reason, the cost savings. That the hardware cost, the cloud resource cost, and the development resource cost.
Cool.
I hope that answered your question, AK.
Yeah, I guess so. Let us know, AK. Tyler asked here, we were talking about that before, performance, and you showed, was ClickHouse in there as well? I don't remember.
Yes, ClickHouse.
Do you want to say a few words about that?
Yeah, it's I showed earlier in the slide, right? When we run this benchmark test against ClickHouse, we saw about two times performance gain. So we're like in about 1.7 to 2.345 in that range performance gain compared to ClickHouse. And as I mentioned, right, performance gain is one aspect of that, but also the we can eliminate majority of the denormalization jobs that is a great cost saving, translates to a great cost saving to our customers, and that's why we have a lot of customers migrated from ClickHouse to Starrocks or CelerData platform.
Yeah, it's ease of use is one of the big things, right? It needs to be simple, and cutting out transformation, cutting out unnecessary work, unnecessary tools. That's very important. That also fits to something I was doing a poll for our event before our event. What makes a good data platform? And 24% said features, and ease of use at 67%. Like, so I think you're on the right track here.
Awesome.
Yeah,
Cool.
Tyler says Airbnb is using the StarRocks, so I guess that would be your next.
Yeah, that's a great segue to the next
Cool.
topic.
Oh, Lee, did you want to cover the Airbnb use case, or I can run through the getting started, and then we can.
Okay, yeah,
let's
do that
okay.
first. Yeah.
Cool. Yeah. So I can share my screen again. I'll just go through how to get started, and then Lee can talk to you guys a little bit more about use cases with StarRocks.
Sure.
So getting started with StarRocks, we have an all-in-one Docker image that you can use to just download to your laptop to get started exploring today. Just find it on Docker Hub under StarRocks. We also have this really nice, if you want to do a cluster deployment and get started quick, we have an AWS Quick Start, which is like a CloudFormation template that you fill out. It works really well. I've done it a lot, and it gives you a cluster deployment right away. You can also choose your node size. So if you want to stay in the free tier, you can. And then you can also download to a cluster. So if you have your own cluster in the cloud, we have documentation that just steps you through. It's really easy because, again, we only have that BE and the FE type nodes, so the front end and the back end. So it's actually really straightforward to configure manually. So if you did want to just deploy a bunch of VMs on a cloud service, you can do that and just install StarRocks. If you wanted to get started with CelerData, we have the enterprise platform that I showed earlier. And then, as Lee mentioned, we're releasing a managed cloud SaaS solution. So that will be, it's like a BYOC, and CelerData will manage the service for you.
How is this going to be? Do you also, are you also going to have a free tier for this, for people to try it out, the CelerData platform, or is that already there?
So StarRocks is open source and free. So if you were interested in the free part, just feel free to get started with StarRocks immediately. Lee, I don't know if you have more information on CelerData. I was not sure about that one.
Yeah, the best way to get started, is to try out the StarRocks open source.
Okay.
Whether it's Docker image or download your own, right? Build your own cluster, or using AWS Quick Start. It has all the performance features, capabilities.
Mm-hmm.
Cool. Let me cover Airbnb use case real quick. So can you bring up that or am I still sharing?
Your screen. I think you need to share your screen again.
Okay, let me share.
Yes.
So, okay, great. So Airbnb has 3 use cases in production now. The first one is Tableau acceleration, right? Andreas, you asked this question, right? Most end users won't be running within our enterprise UI or the command line interface, right? So same as at Airbnb, their business users are running a Tableau dashboards, and they used to run Tableau through Presto and then to query data lake, and those queries take minutes, and obviously that's not ideal for the business users. So they used StarRocks to replace Presto as the query engine on top of a data lake, and they were able to reduce query latencies from minutes level to a couple of seconds. Majority of queries come back within less than 1 second, and the longest took like less than 10 seconds. So that's the first use case, Tableau acceleration. The second one was real-time fraud detection. All these fraudulent activities from the hosts or the guests, right? They need to identify them and prevent them from happening at the moment these guys conduct those fraud activities. So this real-time detection and prevention, they selected StarRocks as the real-time analytics engine to make those decisions and take actions immediately. So that's the second use case. Third one was Airbnb built a enterprise metric store, which enables all the users, employees inside Airbnb to run queries against the data across the enterprise in different databases or files, right? And the end users, most of our non-technical users, they don't need to worry about the data source, the data format, the query language, all those things, right? They just want to make sure to expose this all the information in different backend systems to the business users, to normal users, non-technical folks, through a common metrics layer. That's what this enterprise metric store is about. And Starrocks was used to power this the metric store as its data service layer. They actually gave a talk at the Data and AI Summit back in June this year, and that video is available on YouTube, and we'll be happy to share with our audience after this event. Yeah, so that's the at high level, right? How Airbnb uses Starrocks.
So with this, I have a question about the middle one, about the real-time fraud detection. We saw there that they're getting alarms. How can you do this with Starrocks? Can you create a can you create a worksheet and that triggers something, or how would that be? How would you create this?
Yeah, it's actually, if you think about it, right? It's all your web activities, right? If you're host, your listing histories, if you're a guest, your renting or booking histories, right? And other people's booking history or listing histories. Those are your historical data, large amount of data, and over maybe 2, 3, 4, 5 years history, right? That is the backend. It's like that's your experience, that's your knowledge, right? But also you're dealing with the real-time activities, right? The moment you click browsing the sites and then make a reservation or publish a list, a property, that's the real-time activities. You need to combine that real-time event with the knowledge, the experience you gained over the years, and make a decision, right? And identify any fraudulent activities. So let's say a host to make a claim about certain promotions, or a guest trying to abuse a voucher. That kind of events, there's a lot of quite complex business logic behind it, and you need to take this incoming data maybe coming from on the technical standpoint, right? This information or event started as a simple web click coming through a streaming data source, and then you combine that with your rich historical data, run your analytical queries through maybe petabytes of historical experiences, right? And then make this decision. And you need to avoid any more kind of different outliers, right? So that's why it's quite complex, much more difficult than we thought, and that's why it took Airbnb a long time to pick the right solution to build this fraud detection, real-time fraud detection solution, and we're very happy they eventually chose Starrocks and to start this project. So then next time if you go on vacation and stay at an Airbnb property, just keep in mind Starrocks is behind the scene helping you stay there safely and comfortably.
That's cool. That's a very interesting use case. That's cool.
Yeah, it is indeed.
There was a question, and I asked myself that as well, but I'm guessing it's very early because you said you're implementing this right now. Like, what's the difference in performance with the internal storage and storage? Like I'm guessing S3. Forget about HDFS. Like S3, if you have the data externally on S3.
Yeah, I
there
can take
some
that one.
indications?
Yeah, and let me go through because I'll just be clear about like what we're releasing next month and then what we have today. So the fastest way to like the fastest performance is going to be if you ingest on disk into your cluster. So that would be our storage engine on disk, and that's available. That's what I showed today. The next option is it's going to be released next month, and it would be an object store that's stored. So like for example, you'd have data that's brought into StarRocks, stored in the StarRocks format, and then it's put in the object storage. So that would have a separation between compute and storage.
Mm-hmm.
That's being released next month. That would be, I mean, you might have latency, right? Because you have this, you would have to transport over a network. It wouldn't be connected to the node. But that said, that's going to be pretty minor. And we actually do see cases where there's no difference in performance. So like even if you're using an object store or over a data lake, you're not going to need to make that wide table. You know, you're not really going to need to do those optimizations. You can still get that great features of StarRocks. So then the third option is to go over the data lake with like a Hootie or a catalog manager. And that is available today. So if you did want to use a data lake where your data stays in the data lake and it isn't persisted into StarRocks at all, you can do that today as well. So all of them are really fast, but the fastest option would be to put it into disk. Yeah, and again, you can have both internal and external tables. So if you wanted to do a combination, you could do that.
Cool. Okay. Thanks. That was a good answer. Yeah, guys, we're an hour and 4 minutes in, so we took care of the questions. Where can people find you? Who should they get in contact with? Like, you know, when.
Yeah. Starrocks.io is our website. CelerData.com is, there's tons of great information about the product, right? So you can both either the open source site or the commercial site, both has great educational information there and case studies. Our GitHub repository is another place to get started with, right? Like Rachel mentioned, we have a Docker image, we have quick start on AWS, we have the download, free download for the open source project, right? Mm-hmm. And you can try the enterprise or cloud on CelerData side as well. Feel free to reach out to us. We'll share our contact information with all the audience after this the presentation, and feel free to reach out to us if you would like to have a follow-up conversation.
Yeah.
Quick plug: we also have events, and we have one coming up, right, Lee, in the Bay Area. So check out our site social for that. Yeah.
Okay. Can people find that on CelerData? Or should they go to LinkedIn and check it out there?
Like events, I think, probably LinkedIn would be the best place for that, or through the StarRocks community or like Slack.
All right. Cool. Thanks. For me, as I said in the beginning, it's a very interesting topic. I learned a lot. I hope everybody else also learned a lot. Any resources or tutorial to practice? Lee said a bit about this. Check out the CelerData website. Check out the StarRocks open source version, right?
Yeah, you can do we have documentation, and then you can do that all in one on Docker. That's probably the easiest way to get started if you want to just get started on your laptop.
Yeah, always use Docker for beginners. It's the simplest thing ever. All right. Thanks, Lee. Thanks, Rachel. Thanks, everybody. I hope you had fun. I had fun with this. I learned a lot. And yeah, see each other next time. Bye.
Great. Thank you, Andreas.
Bye.